Welcome to MedTechISO. I'm your host Arvind Rathore, and today we are discussing a critical aspect of medical device development: material selection and biocompatibility testing under ISO 10993-1. Choosing the right material for your device is the foundation of ensuring biocompatibility, and preclinical testing verifies their safety. In this video, I will guide you through the process of selecting biocompatible materials and highlight the preclinical tests required to ensure material safety. Let us dive in. Let us first discuss how to choose biocompatible material. Material selection is one of the most important decisions you will make during the design of a medical device. The materials you choose determine not only the device's functionality but also its compatibility with the human body. Here are the key factors to consider when selecting material. Number one is type and duration of contact. The first step is understanding how the device will interact with the body. Will it touch intact skin, blood, or internal tissues? Is that contact temporary, prolonged, or permanent? Devices with limited contact, such as external monitors, might only need basic biocompatibility, while implantable devices require comprehensive evaluations. This classification is outlined in ISO 10993-1 and should guide your material selection. Number two is known biocompatibility of materials. Using materials with a proven history of biocompatibility can simplify the compliance process. Common materials like medical grade stainless steel, titanium, or certain silicones have well documented safety profiles. However, even these materials must be tested for their specific application. If you are using novel material, you will need to conduct more extensive evaluations to ensure their safety. Number third is intended function and mechanical properties. Materials must meet the mechanical and functional requirement of the device. For example, a vascular stent needs flexibility and strength, while an orthopedic implant requires durability and load bearing capacity. Ensure that your material choice balances performance with biocompatibility. Number fourth is manufacturing processes. Consider how manufacturing processes such as machining, molding, or sterilization may affect the material's properties. Residues from these processes or changes in the material's surface can introduce biocompatibility risk. For instance, sterilization with ethylene oxide can leave residues that need to be evaluated for toxicity. Number 5 is chemical stability and degradation. Assess whether the material will remain stable in the biological environment or if it may degrade over time. Degradation products can sometimes pose greater risk than the original material. For example, polymers used in implants may break down into smaller molecules that need to be evaluated for cytotoxicity or systemic toxicity. By considering these factors, you can select materials that not only meet the functional needs of your device but also minimize biological risks. Now, let us discuss the preclinical testing for material safety. Once you have chosen your materials, the next step is to evaluate their biocompatibility through preclinical testing. ISO 10993-1 outlines a comprehensive set of tests to assess the biological safety of materials. Here is an overview of the key tests. Number 1 is cytotoxicity tests. Cytotoxicity is one of the most basic and universally required tests. It evaluates whether the material is toxic to cells. This test involves exposing cells to extract of material and measuring cell viability. If the material is cytotoxic, it indicates a fundamental incompatibility that must be addressed. Number 2 is sensitization and irritation testing. These tests assess whether the material can cause allergic reactions or localized irritation. Sensitization testing is critical for materials that come into contact with the skin or mucous membranes, while irritation testing evaluates local tissue response. Number third is systemic toxicity testing. This test evaluates whether substances released by the material could harm internal organs or systems after being absorbed into the bloodstream. It is essential for devices with prolonged or permanent body contact, such as implants. Number fourth is hemocompatibility testing. For devices that contact blood, such as catheters or stents, hemocompatibility tests ensure the material does not cause harmful effects like clotting, hemolysis, and platelet activation. Number fifth is xenotoxicity, carcinogenicity, and reproductive toxicity testing. These long-term tests assess whether the material could damage DNA, cause cancer, or affect reproduction. They are especially important for permanent implants or devices used in sensitive populations such as pregnant women. Number six is implantation testing. For implantable devices, implantation tests evaluate how surrounding tissues respond to the material over time. These tests provide insights into the inflammation, fibrosis, or other adverse reactions in vivo. Number seventh is extractables and leachable testing. These tests identify and quantify substances that may leach out of the material under normal use conditions. Extractables and leachable testing is essential for understanding the chemical interactions between the material and the body. Now let us discuss integrating material selection and testing. Material selection and biocompatibility testing are not separate processes, they are deeply interconnected. The data gathered during material selection, such as chemical composition and manufacturing methods, informs the testing strategy. Similarly, the result of biocompatibility tests may prompt you to refine your material choice or adjust manufacturing processes. For example, if a polymer used in the implant shows cytotoxicity due to residual additive, you might switch to a purer grade of the material or add a cleaning step to the manufacturing process. This iterative approach ensures that your device meets both functional and biological safety requirements. Now, here are some key considerations for success. To ensure a smooth compliance process, keep these points in mind. Number one is start early. Material selection and initial testing should begin in the early stages of device development. Delaying this process can lead to costly redesigns later. Number two, work with the accredited labs. Partner with labs experienced in ISO 10993 testing to ensure accurate and reliable results. Number third is document everything. Regulatory bodies require detailed documentation of your material selection process, testing results, and any risk mitigation measures. A well-prepared report streamlines the approval process. Next is iterate as needed. Don't hesitate to refine your materials or manufacturing processes based on test results. Achieving compliance is an iterative journey. So, in conclusion, material selection and biocompatibility testing under ISO 10993 are critical for ensuring the safety and effectiveness of medical devices. By carefully choosing materials that balance functionality and biocompatibility and conducting rigorous preclinical testing, you can minimize risks and ensure regulatory compliance. I hope this video has given you a clear roadmap for selecting biocompatible materials and understanding the preclinical testing process. If you have any questions or need further guidance, drop them in the comments below. Don't forget to like, share, and subscribe to MedTechISO for more detailed insights into ISO standards and compliance strategies. Thank you for watching, and I will see you in the next video.